Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation. And so, as I've said previously, you can literally intuitively say something, use all of the wrong words, but still be identifying something correct. And so I always listen to people's intuition, meaning like the large scale structure of theoretical physics, like what are people trying to say, or even more fundamentally, what differentiation is being made. And so we've kind of arrived logically, what is the difference between speed and velocity, right? If you go into school and or physics class in high school, right, they'll make this distinction, right? In the verbiage they will use is saying, velocity is a vector. A vector has a magnitude and a direction, right? And so that was before we derive this difference of between dimension and direction, right? If you say directions, right, left, right, up, down, forward, backward, you always have like this pair, this natural opposition, which we get from physical stability, but then kind of this physical intuition that you're getting on a line, right? The difference between 2 points is a line. And so when you're taking a speed or a velocity, obviously it's the change of distance. I'm going to stop saying obviously one of these times, but a change of distance over time. And so we make this direction saying speed is a magnitude and then velocity is a vector. And so, right, and then logically and physically, we say the speed of light. So we've made a clear differentiation saying light is not a vector. And so what differentiation are we making there, right? A vector has a magnitude, right? Those are our cardinal numbers, or represented by cardinal numbers. Velocity and vector look similar linguistically, the letters. But magnitude versus magnitude and direction, right? And then we have this independence, physical independence. When you do an integral dx, dy, dz, you treat whatever one you're not integrating as a constant. And so that's like that directionality of things only moving along that difference between 2 points being a line, but really being a tension path. And so, but still this differentiation always just makes me, right, it just echoes to me that work requires movement, but movement in which direction, right? Speed versus velocity. If I'm going 20 miles an hour, right, I'm still going a distance per time. But if I go a velocity 20 miles per hour north, right, it gives me direction. It's reflective of chronology. Again, you start at one place, you go to another place, but I'm still not exactly, why is this differentiation between speed and velocity? Why has it been made? And then again, obviously, we say speed of light, and so not velocity of light. And why is that? When light has no mass, velocity, right? The only things that can move have mass. And so it's probably just that. I don't think, again, there's no other physical, we've already proven there's no other physical properties or ideas or processes to articulate. Everything's derivative, meaning coming from vibration, and vibration being our movement limit at the bottom end, in rhythm, maximizing efficiency and regulating cycles that do work. Again, reiterating, vibration is a cycle that does not do work, and rhythm is a cycle that does do work. And we come from that, again, that orbital stability of charge creating mass is like the fundamental cycle. And so just wanted to talk more about that. Again, the speed versus velocity, direction. What is direction to displacement, right? If something is moving, it is moving in a direction, right? And displacement is the magnitude removed from its starting place. Again, just trying to explore this relationship, what differentiation has been made. But speed is a magnitude, velocity is a speed with a direction. What is work to direction? All right, work requires movement. Movement is displacement. Displacement is directional. Movement is directional. Displacement is change. And so, to me, again, that has something intimately to do with, again, the statement that work requires movement. Movement is this displacement. The rate at which things move is either a speed or a velocity. We've introduced a ton of we've proven physical bounds. But again, I just don't get what speed is. It's like, again, it's like when you say speed of light, it's a propagation limit. And then we talked about infinitesimality pairing to how slow something can move, because again, everything is moving, right? Nothing can be completely still. But I wanted to talk about that, nothing more there. Sensorality differentiates demand. Sensorality is demandality. Sensorality reprimands. Sensorality is primandality. Like reprimand, take off the re. Linguistically, we have similarity between primandality and primality. Sensorality is decisionality. Decision, precision. Memories are sensories. Sories, stories. Sensorality is chronicity. And so we're going to get back to this word chronicity here in a second. Sensorality is complicit. Complicitality consents. Consent agrees. Agreement, containment. Sensorality is consentiality. Sensorality is citality. That's with a C this time, not an S. But minimum is based, right? If you have a minimum and a maximum, again, now we have logical opposition, right? And so limitation contains both, a maximum limit and a minimum limit, right? You can't move faster than the speed of light, and it can't move slower than the infinitesimal limit. But physically, that's, again, you're trying to limit a geometrically odd-shaped physical object. With other physical objects, it's always going to have some space between, because the electrons can't touch. And so what do we got here? Minimum is based, base is limited, sensorality submits. Limiting miniaturizes. And so, again, that infinitesimality, minimum, that strikes me as the same, again, linguistic form. But it just, again, within limitation, we have a maximum limit and a minimum limit. Is that being redundant anywhere? That's what I got for now. Subordination submits. What is the relationship of cyclicity in chronicity? Again, chronic, right, is long-lasting, ongoing, but it's like more of the preservation of the phonetic is why I connected this, or returning to this. But cyclicity in chronicity, like when I think of a chronograph, like I think that's how fast something goes, right? Like a shooting chronograph, where you shoot through the little triangle thing and it gets the feet per second on your bullet. But the cyclicity, chronicity, and then the phonetic pronunciation of chronic to chronicity. Sensorality is chronicity. What is chronology to chronicity? Right? Is chronology chronic? You kind of see again, I don't know what I'm getting at, but it's just connecting our conceptualizations, filling in the blanks of our concepts by building up our logic with our language. And so if something goes on a long time, it's chronic. If things the sequence of things happening is chronology, and then linguistically, obviously, they look very similar. What is discretion to consent? Right? If you consent to do something, you choose to do something. You agree to do something. Discretion is like, have some discretion. It's like other people might not be consenting, and there's clearly a relationship conceptually between discretion and consent. What is electricity to electricality? And so now, to get away, I thought this was a good example where we introduce this new mathematical concept, the inverse of infinity, because infinity doesn't have natural opposition, and we have natural opposition within a bound, but we don't say electricality, right? And so I've never heard of infinitesimality or infinitesimality, but you've never heard of electricality either. And that's the general logical form of electricity, right? We have the physical things, and then the logical generalization so we can connect them to the other things. And so electricality is, again, the same kind of reduction to electricity, where you say electricity all the time and you've probably literally never said electricality. But you can see the limitation, the logical limit presented by iterating the letters. And so one other thing popped ahead in my mind immediately when I was saying that is a stabilized charge. It's okay, how does the electron, if mass is a stabilized dynamic of charge, which it is, then how does, an electron have a negative charge? Again, it's just some sort of internal bound where like the valence shell, like you have an atom where the outer shell is negative. You still have internal dynamic of dichotomy of charge, and then the outer part is negative. And then you still have the same dynamic for the proton, and the outer shell is positive or something. It's just, but mass is charge. Charge stabilized into mass. That is what static electricity is, right? That's an oxymoron. If you rub your head with a balloon and your hair stands up, what's happening? Right? You're creating a charge differential, so it pulls on the electrons of your hair, and your hair is very light, so it not massive, so it sticks to the balloon. So you're creating a charge different without breaking, obviously not breaking the nucleus. Done saying obviously, but again, trying to talk through all of the, but you can't, again, it's just any intuition that feels funny is because of this irreducibility, because we do have genuine measurement limits. But that's what I have for you today. And so thank you for watching, and I will see you on the next one.